Parapatric speciation, continuation of the previous video. In parapatric speciation, there is no specific extrinsic barrier to gene flow. Okay, individuals are more likely to mate with their geographic neighbors. So when we get this picture, we could see that ancestral population is there. A physical barrier divides the ancestral population over time. Each isolated population diverges due to natural selection or drift. There is some kind of habitat gradient that results in locally adapted individuals. The extremes in the population are selected for and there is associative mating. Associative, allopatric speciation, parapatric. Ancestral population. A physical barrier divides the ancestral population. Over time, this is isolated population derived due to natural selection or drift. Allopatric speciation, we know that. And there is some kind of habitat gradient that results in locally adapted individuals like parapatric speciation, hybrid zone. The extremes in the population are selected for and there is associated mating, sympatric speciation within that. So here we could see a comparison of these four types. Allopatric speciation at physical barrier that separated a continuous population resulting in reproductive isolation. Initial step of speciation, geographic barrier formation. Then feature new species geographically isolated from the original population. Charles Darwin's Galapagos finches. Then sympatric speciation. The form of speciation occur inside a continuous population and caused by mechanisms apart from geographical barrier. Initial step of speciation, genetic polymorphism. New species can habitat with the original population in the same geographical region. Patent plants produce offspring that are polyploidy. Hence, the offspring live in the same environment as their parents, but they are reproductively isolated. Parapatric speciation. Speciation triggers by partial isolation, wherein new species budded off from the larger founder species. Initial step of speciation, ecological niche. New species acquired a new niche adjacent to the parent's niche. Because they are only partially separated, the two species may still come in contact from the time to time by crossing the barrier until reproductive isolation is reached. That is parapatric speciation. Peripatric speciation. Speciation triggered by partial physical isolation where the new species evolved as a subpopulation that diverged from the original species. Ecological niche. New species acquired a new or an isolated niche. Evolution laws. Haeckel's law. Ontogeny recapitulates phylogeny. The biogenic law theorizes that the stages an animal embryo undergoes during development are a chronic display or a replay of that species' post-evolutionary forms. Growth of an organism through this embryo stages follow its evolutionary history. Haeckel's law. Then Dollo's law. This law states that an organism never gets back to its original state. Even if the conditions are unfavorable to its previous conditions, still it does not return back to its original state. There are some of the steps in between which the organism has passed its lifetime, which is never able to return back to its original state. Evolutionary reversal. Cope's law. Cope's rule states that evolution tends to increase body size over geological time in a lineage of populations. Evolutionary trends tends to increase body size over geological time in a lineage of populations. Evolutionary trends towards an increase in body size are common in fossil record. In case of Eocene, ancestors of modern horses were about the size of a dog. So organisms generally increase in size from their ancestors. This is possibly due to larger organisms have fewer predators and a larger size protects against many smaller predators. That's coping mechanism like that. So remember like that. Size increase as a coping mechanism and it's Cope's rule. Food utilization is more efficient. Thermia inertia increase, constant body temperature increase in size, decrease in population, decrease in biomass leads to extinction and increased opportunity for others. Evolutionary force involved in speciation, genetic drift. So genetic drift, it is a random change in allele frequencies that occur in a small population. When a small number of parents produce just a few offspring, allele frequencies in the offspring may differ by chance from allele frequencies in the parents. It is also describes random fluctuations in the number of gene variations in a population. So when a small number of parents produce just a few offspring, allele frequencies in the offspring may differ by chance from allele frequencies in the parents. It is also describes random fluctuations in the number of gene variations in a population. Genetic drift takes place when the occurrence of variant forms of a gene called alleles increase and decrease by chance over time. The variations in the presence of alleles are measured by changes in allele frequencies. Initial population, second generation, third generation, fifth generation, fourth generation. Bottleneck effect. Bottleneck effect occur when a population suddenly gets much smaller. This might happen because of natural disasters such as a forest fire. By chance, allele frequencies of the survivors may be different from those of the original populations. Then founder effect. The founder effect is a phenomenon that occurs when a small group of individuals become isolated from a larger population. Regardless of what the original population looked like, the new population will resemble only the individual that founded the smaller distinct population. The founder effect is due to the randomness that accompanies selecting a small group from a larger population. The smaller the population, the higher the chance that the small population does not represent the larger population. If a few organisms that migrate to get separated from the parental population do not carry the same frequency or alleles as the main population, the resulting founder effect will cause the population that separated to become genetically distinct from the original population. This may lead to new subspecies in organism or even rarely new species even through time. Then pattern of evolutionary change, anagenesis. This is known as a phylogenetic transmission of gradualism. Is a mechanism in which one species evolves into another by evolutionary changes within a lineage. The new species completely overwrites the ancestral species, causing the ancestral one to be extinct, as there are no members of the ancestral species remaining. Then cladogenesis. During cladogenesis, one species splits up into two or more groups, in each of evolving at its own path. Until the groups are now different species, the cladogenesis is not mandatory for the parent species or die off. Oftentimes, the parent and daughter species end up living side by side, obvious to the fact that at one point they were some kind of animal. Nature of evolution, microevolution and macroevolution. Evolution involving small scale changes within the species occurring over a short period of time that results in the formation of new species. An allele is one or two or more variations of a mutation at a certain location on a chromosome that is typically known. It is variant form of a specific gene. To simply put it into word, it is a physical trait that gets expressed in a population causing 5 distinct stages. Then microevolution, macroevolution, evolution happening on a large scale at or above the level of species over geologic time results in the divergence of taxonomic groups. Macroevolution can be used to describe the differences between two closely related but distinct species such as Asian elephant and African elephant, which cannot mate due to the barriers imposed by reproductive isolation. This is the process of speciation which can be driven by the number of different mechanisms. Before pesticide application, after pesticide application. Macroevolution, major patterns and changes among new living organisms over time periods of time. Punctuated equilibrium. It is a hypothesis devised to explain a pattern of change in the fossil record and how closely related species appear in nature. This hypothesis states that individual species tend to show little or no change over a long time period of geological time and then enter a period of rapid change which gives rise to new species. Then phylogenetic gradualism. The theory of evolution has tried its model to this rate the prediction that species are always gradually evolving, changing very over time. Tries to model this rate, predicts that species are always gradually evolving, changes very low over time, and there is never a point where a species remains unchanging. It's because the natural world is always changing and species must keep up in world to survive. Fine organisms, individual intelligence. Patterns of recognition, macroevolution, phyletic gradualism. Evolution occurs by gradual accumulation of small changes. This is the Neolithic age of evolution not corresponding to phyletic gradualism. Evolution occurs by the gradual accumulation of small changes. The intermediate stages of evolution not correspond representable forces merely fails to incorporate the missing data. Fossil record, then punctuated equilibrium, that is phyletic equilibrium, then punctuated equilibrium. History consists of phyletically, geologically long periods of stasis or with no equilibrium, interrupted or punctuated by geologically short period of rapid. Next is about phylogenetic tree. What is a phylogenetic? A good rooted tree will be there and unrooted tree. A rooted phylogenetic tree serves as a useful diagram which shows the evolutionary story. It has a basal node which is called the root, representing common ancestor of all the groups of the tree. A root is a tree is considered to be the oldest point in the tree which represents the last common ancestor to all the groups included in the tree. Hence, a root tree allows the direction of evolutionary time when from the perspective of rooted tree. Since the rooted tree depicts the direction of evolutionary time, it is likely to defined entire groups or organisms. Accurate roots of phylogenetic trees is an important indicator generating changes between organisms and their directionality of the evolution. An unrooted phylogenetic tree is an polygenetic diagram which lacks a common ancestor or a basal node. This type of tree does not indicate the origin of tissue of the evolution of the groups of interest. It depicts only the relationship between organisms responsible for the detection of evolutionary changes and before the group's respective time during unrooted tree. Thank you for listening.